Hello friends, today we're gonna learn how to create a 3D model of machine bracket. In CATIA V5, you can create a particular 3D model in a number of ways by using different combination and sequence of operations. We're gonna build our initial model by considering future possible changes into the part during its development because the component may change time to time due to some reasons like changes into the surrounding part, changes into the mating part interface, or due to some reinforcement suggestions after CA analysis. To do these modifications quickly and easily at any stage of the design, we have to build our model properly with proper combination and the sequence of operations. And also we need to keep proper parent-child relationship between the elements and the features. So let's start our design. Rename our part to machined bracket. Rename this input geometrical set as a input. Hide this original elements. Create one point and line. So select this point, then type point and direction. Select direction Z component. Create a new geometrical set and name as bracket construction. Insert axis. Select origin as a point 1 and Z axis as a line 1. Uncheck this current, uncheck under the axis node so you can get your axis system under this bracket construction. Click on OK. Now work in define part body and click on this position sketch. Select YZ plane as a support. Add origin projection point and select the point 1 and orientation parallel to line. Select this y-axis. Click OK. Take a centered rectangle and create a rectangle. Make sure that the center of this is coincide with this vertical axis. Now constrain this bottom face with this horizontal line. Right click and coincide. Give thickness here 18 mm and width 56. Exit from the sketch. Use pad. Here overall length is 75 divided by 2. Make here mirror extend so you can get the thickness or the material on the both side. Now we're going to create a pocket. So create one more position sketch. Select YZ plane again. Origin as a point 1 and orientation as a parallel to line y-axis. Take centered rectangle. Constrain first with this axis system. Make this fix. Make this height 8 mm and width 32. But I want to constrain this with this outer sketch, so whenever you change the outer sketch, this sketch also automatically changes. So I'll convert this dimension into the reference. which I can created with this axis system. I'll create a new dimension between this line and this sketch, the top line and the top line of the sketch. So we can maintain here 12 mm thickness in the base. Exit from the sketch and use pocket. In the pocket, use the time up to last. Click on more. In the second limit, click on up to last. Hide this. Now we are going to create a cylinder. So for that, I have to create some prerequisites. Change the workbench to GST. Create a line at this point in the Z direction and create a parallel on this plane in the reverse direction at 100 minus 28. So this represents the axis of the cylinder. Now to draw a cylinder sketch, I need a plane 36 offset from this base one. So I'll create one plane which is 36 mm offset from the base. Now define the part body again. Create a position sketch. Select here projection point and select this vertex. Select here parallel line and select x-axis and click OK. Now select a circle at the center, coincide to the center. Create one more circle and give dimensions. Outer one is 36 and inner one is 22. But this outer one represents the thickness of this cylinder. So I'll convert this into reference and I'll give the thickness. So whenever you change the inner diameter, outer diameter also changes. Cancel this. I'm going to define also here the rib thickness. Here make it perpendicular to this axis and select this. Give it this dimension. This is 12. Right click on it and click this output feature. Now change the workbench to the part design and select this sketch in the reverse direction at 25 height. But I just control this height by using the dimension. I want to control this by using the plane. So I'll create one plane 25 mm offset. Double click on this and here up to plane and select this plane. Now I want to create the rib here. To create a rib, I'm going to create two planes which defines the thickness of that rib. So create a plane perpendicular to this line at this edge. Create one more plane perpendicular to this line on this end. Now we'll define the part body. Click on the position sketch, select YZ plane, projection point, select this point 1, and orientation, select the parallel line, that is Y. Now create a sketch. Now I'm gonna dimension this first, and I'm gonna constrain the sketch with this another sketches. So coincide this point with the top point, and coincide this corner point with this pocket sketch corner. Now make this axis and this parallel. This point should coincide with this plane. This point should coincide with this point, and the dimension between this and this point is 36. Convert this dimension into the reference and give this dimension. Exit from the sketch. Give thickness now by using pad. So select the sketch. Here type up to plane. Select this plane. Click on more. Second limit up to plane. Select the second limit. Now we have to define the whole position for the bolt. So what I'm gonna do, I'm gonna create one sketch which defines the layout for the hole. So select this plane. Here select the projection point as a point 1, and parallel line is x-axis. Click OK. Now create here one circle which coincide with this h-axis. Make here diameter 12. Center graph. Go to properties and name that bolt radius. Now this bolt needs some flat face for the head. Create one more circle which defines the flat face of the head. This flat face is always 1.5 times of the screw diameter. So click on this, click on f of x, then add formula and select this bolt radius into 1.5. Now on that bolt head, to tighten the screw there will be we need a tool. So that tool thickness should be a 5 millimeter. So consider tool thickness here 5 millimeter. And to accessibility of that tool we need a clearance with this other area. So what I'll do, I'll create one more circle which defines the clearance with this other features. So this should be a 3. Now select this and take this rib limit, right click and make it tangent. Convert this all circles into construction line. Then create one point and make that output feature, make the center also the output feature which defines the whole position, and exit from the sketch. Now we're going to create a plane parallel to and passing through this point. Now move to the GST workbench. I'm going to use a symmetry tool. Symmetry this plane along this YZ axis or YZ plane, and also symmetry this whole position on this YZ. Now change again to part design. Work and define part body. Select this point, select the hole and select the face. So it will automatically coincide with this point. Make the diameter 12 and here make it 12 up to last. Now this diameter, right click in this box, edit formula, and in the sketch 5 select this bolt radius and into 2. Again select this point, select this hole and select the face. Right click in window, edit formula, select this bolt radius into 2. Now our bracket is ready. Hide this, hide all the construction elements, or I can just quickly show the updatability of our model. Suppose if I change this dimension, update, so it is very updatable. If I change the rib thickness, so one more thing, you can see this when I increase the rib thickness, this width is not increasing because we are not defined. We are like created these planes, but we are not added this plane to the pad. So double click on this pad, and here instead of this dimension type, you can up to limit to this plane and click here second up to plane and select this plane, update. So whenever you update a rib here, it will, the width is also automatically change. So here make it 10 and update. Suppose you want a bigger diameter bolt, click on this and change the here bolt diameter to 14. Exit, update. So if we increase the bolt diameter, this face width is also increased accordingly, and we can get here enough space for the bolt. Suppose if we change the diameter of this circle, so in this way you can design very updatable model, and you can modify your design very easily at any stage of your design. This is end of our session. Thanks for watching.